So let's look at number 28. Three identical discs are initially at rest on a frictionless horizontal table with their edges touching to form a triangle, as shown in the top view above. An explosion occurs within the triangle, propelling the disc horizontally along the surface. Which of the following diagram shows a possible position of the disc at a later time? Okay, so with this question, you could think about momentum. That's one way to think about it. But to me, I think the easiest would be not momentum, but center of mass. Okay, my initial center of mass is right here. Remember, center of mass cannot change unless there's an external force. So when these discs push off each other to move in some direction, right, that will be an internal force. Okay, so the center of mass is not going to change. Okay, so I'm looking for whatever happens, the center of mass needs to be in the same spot. Okay, so for this one, I can just look at this and say, okay, the center of mass is about here, right? It's going to be closer to these, and that is not in the same spot, so it can't be A. This one, once again, is going to be shifted over this way, right? And you can see in the Y direction, it is actually in the same area because it's kind of, these are spreading out, right? But that doesn't make sense because it's once again shifted to the left, whereas I want my center of mass to stay in that middle position. Okay, this one is actually going to be shifted to the right. Maybe a little bit here because I have more mass here, right, than over here. So it'll be a little bit closer to the triangle, but it's not in that center of triangle. Okay, this one is actually pretty close. But remember, I have double the mass over here in comparison to right here, right? So I have two masses here and just one here. So it's going to still be shifted over to that left area. And so this one does not have the center of mass in the middle of that triangle. Now this one, you can see how this one ball is much farther over here, whereas these balls are at a shorter distance, right? And so because of that, these two masses will cancel out, will sort of pull the center of mass from this far distance right back into the middle of that triangle. Okay? Remember, I have double the mass here as a comparison to here. So it's going to be sort of 2/3 distance between here and here. Okay? So sort of if this is one, this would be 1/3 distance here, and this would be 2/3 distance here. Okay? And so that would keep the center of mass right in that center of triangle. So the correct answer must be this one right here, which is E.